any other video program on. It hates it. And a very good morning and welcome back to everyone. Thank you very much for tuning again to the Stream School. We are lucky enough to have Mr. Sandwich today for the first of our 2 maths lessons. And this is the first live. This is a live lesson with Sam. Obviously, you've seen Sam a couple of times, but just because it's the first week or 2, we're still inviting all the teachers to give a little introduction. Nisha's with me as ever, trying to coordinate everything and keep it all managed well and make sure that she gets all the links and the extra resources out for you all. I hope you're enjoying the Stream School so far. Please don't forget to share with other people, just so we can all get through this this short period of time together. And with that, I'll give a very good morning to my dear friend, Mr. Sam Winch. How are you, buddy?
Yeah, good. Good morning, everybody. Welcome, and what a lovely day it is again. So, live streaming school seems to be bringing the sunshine.
Yeah, maybe we should do this in the winter and test your theory. Right, Sam, obviously really enjoying your lessons and really looking forward to more from you, buddy. So please just let us know when you want to switch and we'll leave everything over to you.
Brilliant. Cheers, guys. Welcome, everyone. So today, obviously, it's the 3rd day of mathematics this week. And we're going to move away from linear sequences and quadratic sequences, which we did on Monday and Wednesday. However, of course, as all my lessons will start, and the session will start, we'll do a quick recap. So, Nish, if you can share my screen, please.
Cool.
Okay, so first, we're going to fly through 4 questions just to recap what we did on earlier on in the week. So, first question would be, what is the nth term of 2, 2.5, 3, 3.5, and 4? And of course, we're looking at the pattern that goes up by 0.5. So that's 0.5n, and if we find out what the previous number was, it would be 1.5. So answer to the first question is D. That is a linear sequence because there's a consistent pattern each time. Second question is a geometric sequence. What do we multiply each time? And there's a consistent multiplication. There we multiply it by 3 each time. So the answer would be C again, which would be 3. Here we're looking at a Fibonacci question. So what are we adding each time? Here, you add the previous number, so 6 plus 5 equals 11. 11 plus 6 equals 17. So the answer is B. And finally, we moved on to a quadratic sequence. Here, you've got to find the second difference. So first, it goes up by 8, and it goes up to 12, and it goes up by 16. That is a consistent, and the second difference, that's a consistency of 4 each time. We divide that by 2 to give us 2n squared. And then we find the second term, and to find the previous number, it's either A or B. If it goes up by 4 each time, if we go back 4, that will give us the plus 6 as opposed to plus 2. So again, in your GCSEs, you'll get multiple choice questions, a little bit of a process of elimination, and we know that the answer to question 4 is A. So that's what we did earlier on in the week. We've got linear sequences, Fibonacci, geometric, and quadratic. I hope you found that really useful, but I know our good friend Sheila will be doing some sequences stuff, and I can also go over some more stuff as we go through the next few months. But today we're moving on to standard form. So standard form, as you can see on the screen, it's a way of writing down extremely large numbers and small numbers, and to do sums a lot quicker by simplifying, as you can see, the big quantities that you might have. One rule in standard form is that your first number must be between 1 and 10. So it might be 1.3 times 10. It might be 9.8 times 10 to the power of something. And that's what we're going to go through in detail today. The first thing I want to do using my lovely visualizer is to test your test your knowledge on powers of 10. 10 to the power of 6. And we're going to work our way down to 10 to the power of minus 3. So here on my screen, you can see you've got 10 to the power of 6, right down to 10 to the power of minus 3. 10 to the power of 6 simply means, if I can write properly, 10 times 10 times 10 times 10 times 10 times 10. Now, I say simply, it's quite a lot to write down. So in simple forms, if we can write it a little bit easier, how many zeros is 10 to the power of 6? Well, it's just 6 zeros. 6. So we know it as 1 million. 10 to the power of 6 is 1 million. 10 to the power of 5, again, you're going to be working with not 6, but obviously 5 zeros. Excuse that. 1, 2, 3. So we've got 100,000. Here you're going to be working with 4 zeros. You're working with 10,000, and so on and so forth. 3 zeros, 2 zeros, and then we get down to 10 to the power of 1, which is 10. Now, that is 10 times 10 times 10, 6 times, and so on and so forth, down to 10 squared, which obviously means 10 times 10. Now here, anything to the power of 1, just highlight that, anything to the power of 1 is just itself. So 72 to the power of 1 is 72. Now we're looking at going from multiplication, you'll move down into division. So a lot of students ask me, what's 10 to the power of 0? Well, it's 0, because 10 times 0. It's not actually asking that. A theory you could have is that it's asking for 10 divided by 10, which of course gives us 1. So here, anything to the power of 0 is just dividing by itself. 72 divided by 72, of course, gives us 1. So anything to the power of 0 is 1. Right, now, next question. How do we go from positive indices to negative indices? So now we're looking at 10 to the power of minus 1. But 10 to the power of 0 is 1, and 10 to the power of 1 is 10. 10 to the power of minus 1 becomes 0.1. And 10 to the power of minus 2 is 0.01. And if we look at here, 10 to the power of positive 2 is 100. So we're going to simply times 1 by 0. We're going to divide 1 by 100, which gives us 0.01. Again, we're going to divide 1. We're looking at 10 to the power of minus 3. We're going to divide 1 by 1,000, which gives us 0.001. Okay, so there's a breakdown. Once you've got your powers of 10 and you work from 10 to the power of 6 down to 10 to the power of minus whatever, 10 to the power of minus 6, 10 to the power of minus 10, you can see that the pattern decreases in numbers, yet the numbers still stay the same in terms of working with the number 1 and the number 10. Okay, so there's a quick introduction to 10 to the power of numbers, and now we're going to look at converting to standard forms. So the first 3 questions are examples of whole ordinary numbers, and then they're written below in red in terms of standard form. So 40 million is the first number, and to write that in standard form, the answer will be 4 times 10 to the power of 7. The best way to work it out is, remember the first rule of standard form was that your number has to be between 1 and 10. So how could I write 40 million between 1 and 10? Well, of course, I'll just take the first number, which is 4. So now, how many times will I multiply 4 by 10 to get to 40 million? And we've got a decimal point here, as you can see my red pointer on the screen, and we just move it once, twice, 3 times, 4 times, 5 times, 6 times, 7 times to get to the end, and that's 4 times 10 to the power of 7. Okay, I'm going to quickly breeze through these two. We've got 7,900, 7.9, our decimal place goes at the front there. 7.9 is, of course, between 1 and 10, so 7.9 times 10 to the power of 3, because we've moved it once, twice, 3 times. And then finally, a bigger number, if you look, 19,300,000, we put our decimal point here to make it 1.93, it's between 1 and 10, of course, and times it by 10 to the power of 7, so we moved it once, twice, 3 times, 4 times, 5 times, 6 times, 7 times to get to the end, okay? So that is how we convert to standard form. I'm going to give you guys a chance at home. We've got 2 numbers on the screen. I'm going to give you 20 seconds or so. The first question is, write 583 in standard form. So, of course, you may turn that, the first thing you want to do is turn that into a decimal between 1 and 10. The decimal will be 5.83. And then you're going to times it by 10 to the power of something. And if it's 5.83, of course, you're going to move it once and twice. So the answer you should have got for that first one, 5.83 times 10 to the power of 2. Next one, 7,740. Decimal point would go here, and the first part of your answer will be 7.74. And you're just going to move the decimal point once twice, 3 times. So the answer would be 7.74 times 10 to the power of 3, or as we know it, 10 cubed. Okay, so that's how to convert to standard form. Here's how we're going to convert to standard form using negative numbers. So you'll be given in your GCSEs a number starting with 0 point something. So the first one, you've got 0.000376. How do we convert that into standard form? Again, the written rule, remember, you must write your number between 1 and 10. So the first part of your answer has to be a decimal number between 1 and 10. So we've gone 3.76. And then simply again, how many times have we moved the decimal point? This time we're going backwards, so it becomes a negative. So we start here 3.76 and we go once, twice, 3 times, 4 times. So the first part of our answer is 3.76 times 10 power of minus 4. If we look at this one, my answer I'm going to put down is 3.7. Decimal point goes here, we move it once and twice. So 10 to the power of minus 2. Now a much bigger number here, you've got 3.5 to start off with, and we're going to move it once, twice, 3 times, 4 times, 5 times, 6 times, 7 times. 3.5 times 10 to the power of minus 7. So what I'd like to do, we're halfway through, so I'm going to now give you a couple of examples on the screen as to how to complete them into standard form, how to write questions into standard form. Now you will get, there's 3 types of questions in relation to standard form. You may be asked to write a number and convert it into standard form, or you might be given a number in standard form and be asked to convert it into an ordinary number. And that's what we're going to look at in a minute. And finally, you would then be given some addition in standard form. You'd have to solve the question and then answer the sum of the question. Okay, so 967. But of course, between 1 and 10, 967, I'll have to go 9.67 times 10 to the power of what? We'll have 9.67s there, and obviously move it once, twice, to the power of 2. Okay, 166, 1.66 times 10, 1.66, and I'm moving it once, twice, to the power of 2 again. Now this one I can see I might have to work backwards, so it's going to be 10 to the power of minus something. As a decimal, I can go with 5.77 times 10. And how many times have I moved that backwards? Just once, so it's minus 1. A little bit longer here, we're going to go with 3.4 times 10. Decimal place goes in there, and we just move it once, twice, 3 times, 4 times, so we've got minus 4. And finally, 89.1, we have 8.9 into standard form. And if we go back to my PowerPoint, you can see that we're moving from converting into standard form, we're converting from standard form. A couple of examples for you on the board. 1.01 times 10 to the power of 3, or 10 cubed. Write it as an ordinary number. Again, you're just moving that decimal place 3 times to get your answer. Same with the one below, 7.9 times 10 to the power of 4. We're just going to move our decimal place from 7.9, and we're going to move it along 4 times. 2.436, our decimal place will start there. And because it's a negative, we're going to work backwards. We're going to move it backwards 4 times. Okay, so I am just having a look at the time, and we have got time, perfect, to do a couple of examples on the board, or on the table, if you like. Okay, so 9.84 times 10 to the power of minus 4. So I know the number.
9.84 times 10 to the power of minus 4 is 0.001.
I apologise. That's my
It's
Alexa.
okay.
That literally my Alexa heard what you said, and then it tried to do the calculation. Sorry.
I wondered if my voice had changed. That's fine. That's great to hear. So 9.84 times 10 to the power of minus 4. What we're going to do now is move the decimal place, which is currently here, and I'm going to highlight that in the black pen, and we're going to move it back 4 times. Okay, so I might just throw in 4 zeros. I'm going to move it once, twice, 3 times, 4 times. So the new answer is 0.000984, and that's how to convert it from standard form into an ordinary number. Okay, let's do a couple more questions. 72800, and we're going to go once, twice, 0.0728. I'm just trying to see if we can go through these. 3.97. 3.97 times 10 to the power of 1. So we're just going to move it up once because it's a positive number as opposed to a negative number. So I'll write that out again. It becomes 39.7. Here, 9.37. The original decimal point was there. And we're going to move it back twice. Once, twice. And finally, 1.95. Write out the number 1.95. And it's 10 squared, which we know as 100. I'm going to move it once, twice. The answer to be 195. 195. Okay, so that is converting from standard form. We've done a little bit on converting to standard form. Now, bearing in mind, 4 minutes left. We're looking at using now addition, subtraction, multiplication, and division. My suggestion here would be to do the brackets. Do each bracket one at a time, and then once you've done the bracket, go back and write out the question. So similar if you were to do a big maths question, if you like, and I'll give you a couple of examples for us to finish off on. But the first question, you've got 9 times 10 to the power of 0, add 2.5 times 10 to the power of 0. Of course, we know 9 times 10 to the power of 0 just to be 9. 10 to the power of 0, or anything to the power of 0, is just 1. 9 times 1 is 9. Add 2.5 times, in effect, 1. So 9 add 2.5 obviously gives us 11.5. Again, let's break it down. 1.5 times 10 to the power of 1. 10 to the power of 1 we know is 10. 1.5 times 10 is 15. We've got 15 here. And then we're going to take away 1 times 10 to the power of 0. We know 10 to the power of 0 is 1. We know 1 times 1 is 1 still. So we've got 15, take away 1, which of course gives us 14. Similarly over here with division, 7 times 10 to the power of 7 times 10 to the power of 1, which gives us 70. And you're going to divide that by 2 times 10 to the power of 0, which just gives us 2. 70 divided by 2, nice and easy, is 35. And finally, on multiplication, 8 times 10 to the power of 1 gives 80. And we're going to multiply 80 by 5.5 times 10 squared, which gives us 550, which 80 times 550 would give us 44,000. That was a little harder for me to work out off the top of my head. Okay, so let's have a look at an example sheet for you. So here's 4 questions. And if I can just fly through these, we've got 5 times 10 cubed plus 7 times 10 to the power of 1. So let's do a bracket at a time. We know that 5 times 10 squared is 500, 5,000, sorry. And 7 times 10 to the power of 1 is 70. Of course, 5,000 add 70 gives us a grand total of 5,070. Big job, mate. Here we've got 9 times 10 to the power of minus 1. Well, we know 9, as we did earlier with standard form, we know 9 times 10 to the power of minus 1 means we're going to move our decimal place back 1. So that gives us 0.9. And 5 times 10 to the power of minus 1 means we're going to move our decimal point back 1. What's 0.9, take away 0.5, gives us a grand total of 0.4. And the final 2 questions we've got, before I run over time, we've got 9 with 4 zeros multiplied by 6 and, 6 and 5 zeros. Decimal point should go there, all that. And then to work this one out, nice and simply, we do 9 times 6, which gives us 54. And I could actually cancel each 0 out. 1, 2, 2, 3, 3, 4. 4, and I'm left with 1 0, so that means the decimal place moves back 1. So the answer there will be 5.4. I'm aware that we've run over time, so division and multiplication, I want to just recap next week, and I'll see you. In fact, Nish, can you put it back on screen, please?
All right.
Yep.
So-
Thank you, Sam.
Yeah. So so that's standard form. We've managed to do 3 or 4 week lesson in a space of about 19 minutes. So I will hopefully recap some more on Monday. As I said, I think Sheila wants to do some more standard form as well, which would be great to listen to her. But I hope you enjoyed today's lesson, and I'll see you guys on Monday, and enjoy the sunshine. Stay well.
You're a gentleman, Sam. Thank you so much, buddy. I hope you get a lot of time enjoying your walk, the daily walk that we're currently on. And just have fun with your family, buddy.
Cheers, guys. Take care.
Have a great weekend, pal.
See you later today. Bye-bye.
Nish, we've got to work out how we can do it where we stop pinning it so it just goes back and forth between people.
Do you just click the same screen?
I don't know. We'll find out at some point in the break. Right, I'll leave it to you to lead out, Nish. Thank you very much. And then we'll be back and just let us know what's coming up next.
All right, cool. So this is the optional task for Maths GCSE. This is just the first 4 questions. There is a whole document, which would be great if everyone would do it. So it is all about standard form. The first ones start off as just writing the numbers in standard form, and then there will be some addition, subtraction, multiplication, and division of standard forms as well. And the next session is going to be science.
Oh, wonderful, wonderful. We get to listen to Michael Scott's dulcet tones again.
Yeah.
And today, again, guys, you have a 4th lesson today where we have a session from Miss Sheila Barlow as well, another maths teacher, and this is going to be focusing on higher maths. So it's going to be a different level of maths than we're having with Sam as well, less general, kind of more looking at some of the higher aspects of mathematical range. Look how I'm just trying to find words for high maths when I don't know any of what happens in high maths. Like, yes, top and high. Yeah, I'm just going to give up. Thank you so much, as ever, Nish. I will see you in another 15 minutes or so.